All right, lastly, we want to look at the case for trig sub of the form integrals that contain x squared plus a squared or a squared plus x squared. It doesn't matter because addition is commutative. In those cases, we are going to perform the following substitution. We're going to say x is equal to a tangent of theta. The domain that we are restricting our theta to is negative pi over 2 to pi over 2. And the identity that we will likely use in this case is the Pythagorean identity of this form. 1 plus tangent squared theta is equal to secant squared theta. Now note that this creates this relationship, which generates this triangle, which means this side is x squared plus a squared square rooted. And dx is equal to a secant squared theta d theta. All right, so let's look at an example where we use this substitution. So let's say we have 1 over x squared square root of x squared plus 4. Change it up a little bit, dx. Here my a is 2, so we're going to say x is 2 tangent theta, which means dx is 2 secant squared theta d theta. It generates this triangle, x squared plus 4. So any trig function that we need to pull out, we can get from this triangle based on our substitution. All right, so then this integral becomes 1 over that x squared is 4 tangent squared theta, that's just x squared, square root of 4 tangent squared theta plus 4. And then a lot of times people just forget and put a d theta there, but remember that's not right. We need to replace dx with this entire expression. So times 2 secant squared theta d theta. It's a common mistake, so just be wary of that. Okay, so again, when we're from negative pi over 2 to pi over 2, secant, open interval, right? So then cosine looks like this on that interval, and it is positive. So is secant is positive and defined as long as it's not 0, which it isn't, because that happens at negative pi over 2 and pi over 2. Okay, so then this becomes, we'll just write 2 secant squared theta here over 4 tangent squared theta, and then this whole expression should become 2 secant theta, right? Just make sure we all see that. We can pull out the 4. This becomes tangent squared theta plus 1. Actually bring that out, and then that becomes the square root of secant squared, which is 2 secant theta because secant is positive on the restricted domain. Okay, d theta. Now we could do some simplifying. One of those, those 2's go, and then one of those secants goes. So now I have secant theta, I'm going to bring out the 4, over tangent squared theta d theta. Now this is maybe should involve some maneuvering. This is not quite of the form tangent and secant because we're involving a denominator now, so it's really like cotangent or cosine. So we could write this as, so tangent squared is really cosine squared theta over sine squared theta, right? That's what 1 over tangent squared is, or cotangent squared is, and then secant theta is really 1 over cosine theta d theta. So that cancels with one of those. So now I have 1/4, I'm going to write it as 1 over sine squared theta cosine theta d theta. Now I see a u sub. We will let u be equal to sine theta, then du is cosine theta d theta, which I see right here. So this becomes 1/4 u to the negative 2 du, or 1/4 u to the negative 1 over negative 1. We got to go back to sine, so it's really negative 1/4 1 over sine of theta, or negative 1/4 cosecant of theta, all plus c. But so we went from u back to theta, but now we need to go from theta back to x. And so we go to our triangle. Cosecant is going to be hypotenuse over opposite. So this should be negative square root of x squared plus 4 over 4x plus c. And that's it. Go practice.